Hello, and today I'm going to talk about trigonometry ratio for this pre-calculus trigonometry course. So let's say if we have a right triangle, we already know this side 3 centimeters, this one 2 centimeters, and we know that we don't know this, and well, we can easily find this one by Pythagorean theorem, right? But how do we find the angles of this? We know that this is 90 degrees, and but we don't know this angle and this angle. So that's where trigonometric ratio comes in. So if you have a right triangle here, sorry about this, um, right triangle, this is an angle theta. Okay, we use a Greek letter to denote angles, and the side that is facing uh, the angle is called the opposite, the opposite angle. I mean the opposite side. And this bottom here is called adjacent, and this here is called hyp- the hypotenuse. 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 Well, uh, to find the angle theta, we use something called SOHCAHTOA. So we have sine theta and cosine theta and tangent theta. These are the main trig ratios. And sine theta here is our opposite over our hypotenuse. So it's our opposite over our hypotenuse. And our cosine here, cosine theta, is our adjacent over hypotenuse. Adjacent over hypotenuse. Okay? And our tangent here is our opposite over our adjacent. Well, in trig identities, tangent theta is actually sine theta over cosine theta. Is the ratio between, yeah, tangent theta is the ratio between sine theta over cosine theta. So you can see sine theta is opposite over hypotenuse. So opposite over hypotenuse and over adjacent our cosine theta, adjacent over our hypotenuse. Well, we can simplify this, and this will become times, right? And so it becomes the hypotenuse over adjacent. This cancel out, becomes opposite over adjacent. Well, you can think about tangent theta is also our slope. Well, if you have, is that right? Slope, and this is our run. Yeah, this is our run and rise. So our tangent theta here is just actually our rise over run. Okay, Well, let's get into some practice. So let's say if we have a right triangle here and we have this length, which is the adjacent 5 centimeters, and we don't know this one, so we call it x, and this is y, and we know that this angle is 32 degrees, and this is an unknown angle. Let's call it alpha, and this is 90 degrees. And we're told to find, of course, our alpha and x and our y. So, what our trig ratios that uses opposite and our adjacent? Well, to find x, right? So, we have our tangent. So, remember, tangent theta is equals to the opposite over the adjacent. Okay, and well, our degree is just tangent of 32 degrees is equals to the opposite x over the adjacent 5. Okay, and our x using simple algebra times 5 on both sides, we'll get 5 tangent 30 degrees, 32 degrees, 2 degrees is equals to x. Well, using our calculator, 5 times tangent of 30 is just 2 approximately approximately 2.89 centimeters. That is our x. So our x is equals to 2.89 centimeters. Well, to find our y, just use Pythagorean theorem. So our y squared is equals to our x squared, or our 5 squared, plus by our x squared, 2.89 squared. So our y must be the square root of 5 squared plus 2.89 squared. So using the calculator again, square root of 25 plus 2.89 squared is just approximately 5.78 centimeters. So this side is 5.78 centimeters. Well, we haven't found our alpha. We know that the sum of all angles in a triangle is 180, right? So 180 is equals to alpha plus 32 plus by our 90 degrees, and our alpha must be 180 minus by 122, okay, which is 58 degrees is our alpha. Okay, next we have a right triangle. 3y 7. We don't know this angle. Let's call it alpha. And we don't know this angle also. Let's call it beta. Okay. Well, as you can see here, we got two known sides and one unknown side. Well, we can figure out y easily. Y is just the square root of 7 squared minus 3 squared. Well, that's just 49 minus 9. Square root of 40 to square root of 10. Okay? And centimeters. Don't forget the unit, centimeters. So y is 2 square root of 10 centimeters. What's our beta? Well, we can use sine, cosine, and tangent. So, well, let's say we use tangent. So we know our y equals to 2 square root of 10 centimeters. So tangent of beta is equals to our opposite over our adjacent. So 2 square root of 10 over 3. Well, to find beta, uh, we need to take the inverse tangent. So the undo tangent. Well, that undoes this to become a degree. So beta is equals to tangent inverse of 2 square root of 10 divided by 3. Well, the tangent inverse of 2 square root of 10 over 3 using your calculator is tangent inverse of 2 square root square root of 10. And then all of that over 3. That is just approximately 64.62 degrees. Okay, that's our beta. So our beta here is approximately 64.62 degrees. That's our beta. Well, we can figure out alpha. So our alpha, so around 80 degrees is equal to alpha plus beta, 64.62 plus our 3, plus our 90 degrees. So 90, we have alpha plus 64 plus 64.62 plus 90 is 154.62 degrees, 180. 180 minus by 154.62, we have 25.38 is equal to our alpha. Okay, so our alpha is 25.38 degrees. That will add up to 180. Okay, great. Let's move on to the next question. So we have this right triangle facing downwards. And we know this side is equals to 3, this side equals to 2, and this side is equals to alpha. We don't know this side and we know this side. Well, we can find our here um adjacent, hypotenuse here. So our hypotenuse, let's call it r, is r equals to square root of 3 squared plus 2 squared, square root of 9 plus 4, which is just 13. Okay. So our r is the square root of 13. Well, we can find beta here. Well, this is our opposite side, right? The length facing to the angle beta. So, and we can use either of this. So we can use sine, cosine, and tangent. Well, let's use our cosine here. So our cosine of some angle theta is equals to our adjacent over our hypotenuse. So in here, our cosine is beta. So cosine beta is equals to adjacent. This is our adjacent side. 2 over our hypotenuse side, square root of 13. Square root of 13. So again, we use the undo cosine, which is cosine inverse of 2 square root of 2 over square root of 13. Well, let's just cosine inverse of, use your calculator, is 2 over square root of 15. Oh, 13, sorry. And that's just approximately, or beta is approximately 56.30. Well, just leave it as 56.3. Oh wait, this is one. We're on, okay, 56.31. And, well, we found our beta. That's our beta, 56.31. And we can find our alpha on an AD minus 56.31 plus minus by our 90 degrees on AD minus 146.31. Well, 180 minus 146.31 is equals to, or alpha, okay, is equals to 33.69 degrees is our alpha. Okay, nice. We found all our degree, our angle, and our side. Let's go to another question. We have a triangle here, and we have this 90 degrees. We have 32 degrees. And we need to find this side, our x here. Well, never mind. Wait, sorry. It's supposed to be, we find the total length here. or x, and we don't know. We know that this point here, let's call it A, B, and A to B is 2 centimeters. And our 5 here is 5 centimeters. And we don't know this angle. Well, let's call it this angle beta, this angle alpha, this our angle theta. Okay. And we want to find this also, the whole length here. This, let's call it C. So we need to find AC, and we need to find our of course angle alpha, beta, and our angle theta. Well, we can find our angle theta easily. Our angle theta is just 30 to 180 means by 32 degrees minus by 90 degrees. Okay. And we have here 90 degrees minus by 32 degrees. We'll have here 58 degrees. Okay. So our theta here is 58 degrees. What's our, well, what's our beta alpha and AC? Um, we can find our beta here. What we just need to know what trig ratio using hypotenuse and our adjacent here. Well, it is just our cosine theta, right? So our cosine beta is equal to our adjacent here over hypotenuse. So 2 over 5 is our cosine beta. And our beta must be cosine inverse of 2 over 5. Well, cosine inverse of 2 over 5 is approximately 66.42 degrees. And well, using this knowledge, we could find our alpha, 6.42 degrees. So our alpha here must be 180 degrees minus by our 66.42 minus by 90. 180 minus by 156.42. Well, 180 minus by 156.42 is 23.58, okay, degrees. That's our alpha, 23.58 degrees. Okay. And 32, well, as you can see here, 32, well, that's 32 plus beta plus our theta plus alpha. So theta plus alpha here, theta 58 plus our alpha, 23.58. Okay. is 81.58. So this is 81.58 degrees. So let us see if it checks out. Does all the angle here adds up to 180 degrees? 32 plus beta. Uh, so 81.58 plus our beta 66.42 plus our 32 degrees. Well, as you can see here, if you add these, this become um 4 or 47.8 plus 32 is equals to 180. So this checks out, and that means we can find our here our AC here. Well, to find AC, we can use our trig ratio here. Wait, we have to find our opposite side here. Let's call it A accent. So A accent is equals to the square root of 5 squared minus 2 squared. Okay, and that becomes 25 minus 4, 21. Square root of 21 centimeters. Well, so this is square root of 21 centimeters. We can find our length here. AC. So our AC, we have to use trig ratio that uses square root of the opposite and the adjacent, which is tangent. So tangent of 32 degrees is equals to opposite square root of 21 over our adjacent. Well, the total length is x and this length is 2. So this length AC must be x minus 2. So x minus 2. Okay. Well, we can find, if we times both sides by x minus 2, we'll have x minus 2 times tangent of 32 degrees is equals to square root of 21. And, well, x minus 2 is equals to square root of 21 over tangent 32 degrees, which leaves us with x is equals to square root of 21 over tangent of 32 plus by 2. Okay? So our x here is equals to square root of 21 over tangent of 32. And then we plus by 2. Plus by 2. So it will become approximately 9.33 centimeters. There's our x here. So our x is approximately 9.33 centimeters. Well, we know x now. We can find AC, substitute x into the x minus 2. So it's 9.33 minus 2. So our AC here is 9.33 minus 2. and that would become 7.33 centimeters. Okay, nice. So this is 7.33 centimeters. Well, we can find our um accent C accent. So our A accent C is just the square root using Pythagorean theorem. Square root of our AC here, 7.33 squared. 7.33 squared. And plus by square root of 21 squared is just 21. Okay, nice. Well, using your calculator, we'll get 7.33 squared plus plus by 21. Okay. Sorry. 21. And this will become approximately 8.64 centimeters. Okay. So our hypotenuse side here is 8.64 centimeters. Okay, cool. Well, we found every unknown side and angle. Okay, next question we have here our, sorry about that, we have our angle theta here. We don't know that angle. Oh, sorry, it's 60 degrees. 60 degrees, and this side is 28, and this side is 30 degrees, and this side x here. Well, we have to find every side and every angle here. And well, if you see here, we can use the trig ratio that uses the opposite and also the adjacent. So that the trig ratio that uses it is tangent theta. It's adjacent over opposite. I mean opposite over adjacent. And our opposite here, which is just 28 over adjacent, we don't know. Let's call it k. This is x, okay? Okay. Oh, it's similar, so let's don't use k. Let's call it f. So our this side f, our adjacent side, tangent of 60. And using algebra, f equals to 28 over tangent of 60. Well, tangent of 60 has a special value. If you remember the unit circle from the last video for trigonometric course in the introduction, well, tangent of 60 is just, uh, well, we have learned this. So sine of 60 over cosine of 60, as I said before, it's just the ratio between sine and cosine. And our sine of 60 here is just a half square root of 3. And cosine of 60 is just our half. So our tangent of 60 here is just square root of 3. Well, we're not gonna learn that right now. So let's just use our calculator here. So our f here is 28 over tangent of 60. So 28 over tangent of 60 is just f is approximately 16.17 centimeters. That's our f. Okay. Well, we found f. Now we need to find our total length here. The total length of the big triangle. As you can see, there's two triangles here. The one with 60 degrees and the one with 30 degrees. So we know that this part f here is our f, of course, and this part here is x. And we know that this is 28. Notice that we can use a trig ratio. Well, that uses opposite and adjacent again, which is tangent. So tangent of 30 is equals to the opposite 28 over f here, f plus by x. So 16.17 plus by f, plus by x. Well, using algebra, we'll have 16.17 plus x is equals to 28 over tangent 30. Again, tangent 30 is a special angle, but we're gonna not use square root as the final form. We're gonna use decimals right now. So 16.17 x is equals to 28 over 16.17 plus, oh sorry, or tangent of 30, tangent of 30 minus by our 16.17 using your calculator. 28 over 30 degrees, and then we minus by 16.17. Okay, well, we have x is equals to 32.32, well, approximately 32.33 centimeters. Okay, nice, we found x. Well, and we found our x, so our whole length here, f plus x, is, so the whole length here is just 32.33, 32.33, 33 plus by 16.17. Well, it's equals to, this adds with, it's gonna 48.5. Yeah, okay, 48.5 centimeters. Okay, that's the whole length of that. And well, using that information, we can find this here, our hypotenuse side. So our hypotenuse side is just, let's call it h. H is the square root of 28 squared plus 48 squared. 48.5 squared. Using your calculator, we have 28 squared plus by 48.5 squared. Okay, it's approximately 56.00. What are we gonna do? 56 centimeters. Okay, nice. Now, what is this angle? It's 180 minus 60, 120. Um, to find this one, this angle here, this angle, well, 30, 90, and an angle, let's call it theta. So this angle theta here, or angle theta is just 180 minus 90 minus 30. 180 minus 120, well, it's 60. Theta is equal to 60. So this angle here is 60. Okay, well, cool. We found every side and every angle. Well, not yet. Sorry, we haven't found this one. This side here. So this side we use F. Oh, just use Pythagorean theorem. So we have, let's call that F accent. So our F accent is equal to square root of 428 squared plus by our F, which we already got 16.17 squared. Well, that's just, so the square root of 28 squared plus 16.17 squared. Well, it's approximately 32.33. So that side is 32.33. Oh, well, this the same um length as our x here. So f(n) is 32.33 centimeters.